So now we are going to start to talk about Lewis structures. You have seen pictures of Lewis structures, even if you didn't see them in physical science. They're a way to represent a compound. Okay? They're a way to create a visual representation of a compound. Now, just like we said about Lewis dot diagrams, are the little atoms really shaped like that? No. No. They're not. There's no little tiny F on each atom. There's no little tiny N on each atom. They're a way to represent the atom visually so that we can wrap our brains around it. Lewis dot diagrams are the same thing. They're a way to visually represent compounds and polyatomic ions so that we can get our little tiny brains around them. But they aren't a particularly realistic representation. Next week, we will do a lab. We will do a Lewis dot diagram. Then you will build the structure out of model parts. And those are a more realistic representation. These are just a good shorthand visual trick. So, it is a formula, and you show the atomic symbol that represents the nucleus of each atom, which is what's happening in our Lewis dot diagram. In our carbon Lewis dot diagram, we have a C with a dot on each side of it. That C represents the nucleus. Those dots represent the valence electrons. The same thing carries over to Lewis structures. In a Lewis structure, when two atoms are sharing electrons, we represent it with a dash. Just a little line between the two of them. If we look at our Lewis dot diagram for fluorine, how many different bonds can fluorine form? So it's already full. Hold up fingers. It's already full on three sides. Which side can it bond on? Just one. Those three sides that are full are pairs of electrons that fluorine will not share with anyone. We call those, this is very creative, unshared pairs. I know that's really hard to remember. Pairs of electrons that are not shared with another atom are called unshared pairs. Sometimes unshared electron pairs, if we want to get really crazy. So we're going to practice some Lewis structures. Okay.